Okay, guys. So yesterday, you know that we had started with the phenols, the hydroxy compound, and in the hydroxy compound, we had done with uh, uh, the phenol and its acidic character. Phenol is a weak acid, and I told you about the strength of different acids. Okay, so different acids, the strongest one that is the mineral acid. Then on second number you got the carboxylic acid. The third number you got uh, phenol. Then you got the water, and then you got the alcohol. Okay, so all these acids, my dear, they have got different strength values. So now what we are going to do, we are going to start with the next thing. We are going to start with the preparation of phenol. Okay, so let's start with it. It's a little bit difficult, but I want you to emphasize on it. Preparation of phenol. Okay. So from how could we prepare the phenol? What is the method of it? Phenol, my dear, it could be prepared from the benzene, okay, by 4 steps. Okay, so if you want to change the benzene, okay, you want to change the benzene into phenol, so there are the 4 different steps, okay, we should follow in order to make the phenol. So let's start one by one with each step. So let's start with the first step. In the step one, we should take the benzene. So this is my dear students, the benzene. Okay, so this is the benzene. You know that benzene could react with the 4 substances I told you. What are those 4 substances? The first substance, chlorine. The second one, that is bromine. The third one, that is halogen derivative. And the fourth one, that is nitric acid. Okay, so if you want to prepare, my dear, the phenol, the first thing you should do, you should react it with the nitric acid, HNO3, and concentrated sulfuric acid that would be used as a catalyst, and 55 degrees Celsius temperature. So we people have done this reaction, okay, in the benzene chapter. So what would happen? This is the benzene. So with the benzene, what would happen? The nitro group that would be attached, and you will get the water. So this reaction we have done in the benzene. So this reaction is also called as the nitration reaction. Always keep remembered when anything react with the benzene, that is called as the nitration. Why? Because nitro group that is attached with the benzene, so that is why it is called as the nitration. Okay, so this is the first step. You should change the benzene into the nitrobenzene. Okay, now come towards the step two. In the step two, my dear, what should you do? You should take the nitrobenzene. This is the nitrobenzene. Okay, and now the second step is actually the reduction step. This is the reduction step. In this step, you should take the nitrobenzene, you should reduce it with the hydrogens. And for the reduction of nitrobenzene, normally we use tin plus concentrated HCl. Okay, so keep remember the symbol of tin is Sn. Sn plus concentrated HCl. So both meaning same. Okay. So tin plus concentrated HCl, it's a reducing agent. So what does
सर
it? जी बोलिए जनाब.
सर ये स्टेप वन में नाइट्रेशन लिखा हुआ है सर
जी जनाब नाइट्रेशन लिखा हुआ है.
ठीक हो गया सर
अच्छा जी. So tin plus concentrated HCl, that is going to provide the hydrogen. So what does this hydrogen do? This hydrogen is going to take out the oxygen from this nitro group. So you got the 2 oxygen, so 2 water that is being formed. Okay, so 2 oxygen would come in the 2 water. Okay, now this nitrogen that would become alone. So if you look up here, this is the nitrogen now. Now, with this nitrogen, my dear, the hydrogen of this one, they would be attached. So it would become NH2. So this thing formed, that is the phenylamine. Phenylamine. So up till now, we have done the two steps. In the first step, we took the benzene, we do the nitration. Nitration means we reacted with the nitric acid and concentrated sulfuric acid as a catalyst. The NO2 group that is attached, so nitrobenzene is formed. In the next step, we do the reduction of the nitrobenzene. For reduction, we use 10 plus concentrated HCl. This 10 plus concentrated HCl that provides the atomic hydrogen. This atomic hydrogen take out the oxygen from here to form water, and we got the N up here. With that N, the hydrogen that would be attached. So phenylamine, my dear students, that would be formed. Okay. Now comes towards the step 3. This step 3 is little bit difficult, and it will come in the next upcoming chapter as well. So please just focus up here. Please, everybody just listen this whole thing very carefully. I'm going to draw this phenylamine up here. So this reaction is called as the diazotization. What is meant by the word diazotization? So let me tell you about it. Have a look up here. This is phenylamine. So this is phenylamine. Okay. If you are supposed to react this phenylamine with nitric acid. So this is called as the nitric acid. HNO3, that is the nitric acid. HNO2, that is the nitric acid with HCl. Okay, so these two things you require. Now, the basic problem up here, my dear, this is phenylamine. Okay, so if you react it with the nitric acid HNO2, okay, so HNO2 nitric acid, it is unstable at room temperature. It is not stable. Okay, so it means if it is not stable at room temperature, so if you put it at the room temperature, it will decompose. Okay, it will break down. So it means if we want to use it in this reaction, we have to freshly prepare it. So to freshly prepare this nitric acid, my dear, normally we take NaNO2 plus HCl. Okay, this is excess of HCl. Okay, so now this one would form HNO2, HNO2. Okay, HCl is excess, so this is already present. So in the paper, they are normally going to mention these two things instead of HNO2 and HCl. Okay, because these things they would form HNO2, and HCl is excess, so it is already present. NaCl is also formed, but we don't know we don't need the NaCl. If it is present, doesn't matter. Okay, so keep remember in the paper, at the place of these two reagents, HNO2 and HCl, normally they write NaNO2 and HCl. Okay, so if they wrote these two things or wrote these two things, both mean diazotization. Okay, so now what would happen up here, guys? All the hydrogens and oxygens, they all are going to form water. So how much hydrogen we got? 1, 2, and 2, 4. So 2 2s are 4. And how much oxygen we got? 2 oxygen. So 2 oxygen is present in the 2 water. And what is being left? Have a look up here. Everybody just listen. So this is the benzene. Okay. So we got this nitrogen. This is the nitrogen. Positive charge on it. This is the other nitrogen. So triple bond N and then Cl minus. Okay. So why this nitrogen is positive? The reason is that you know that nitrogen normally have to make the 3 bonds. But this nitrogen has made 1, 2, 3, and 4 bonds. Why? Because it has delocalized its lone pair. It has so not delocalized. it has shared its non pair forming the dative bond. Okay, so that is why this one got the positive charge. You can write it like that, or you can write it like that in short form, benzene and N2 positive and Cl minus. So this thing that is called as the diazonium chloride. And this diazonium chloride, my dear, it is very important. Keep remember, दुनिया में जितनी भी dyes होती हैं, colors होते हैं, उन सब का starting material that is diazonium chloride. इसको हम लोग अपना जो ऑर्गेनिक नाइट्रोजन कंपाउंड वाला चैप्टर है इसकी तफसील वहां पे पढ़ेंगे, लेकिन यहाँ पे इसका यूज आ गया फिनोल की प्रेपरेशन में. नाउ लिसन अगेन गाइस, व्हाट वी हैव डन, वी वांट टू प्रिपेयर द phenol from benzene. So there are four steps. In the first step, I react the benzene with nitric acid, NO2 is attached, nitrobenzene is formed. In the second step, I do the reduction of nitrobenzene with tin plus concentrated HCl. So this tin plus concentrated HCl, it has taken out the oxygen from here. So hydrogen and oxygen, it has formed the water. And this nitrogen is attached with hydrogen. So total 2 to the 4 and 2, 6 hydrogens they are used. Now this phenylamine, my dear, this is the phenylamine. I wrote it like that. I reacted with nitric acid and HCl. I told you nitric acid is unstable at room temperature. So what I'm going to do, I'm going to take these two reagents, mix it, we will get the HNO2. So at the place of these two in the papers, mostly he wrote NaNO2 and HCl, which means that these two things, HNO2, that would be formed, HCl is excess, and NaCl is also formed, which we don't use. Okay, which is of no need for us. Okay, so when these things would react, all the hydrogen and oxygen they would form the water, and what is left? Nitrogen, nitrogen, and Cl. So it would be N positive triple bond and Cl minus. So you can write it like that: diazonium chloride. This is diazonium chloride. This is your step 3. Now the last step, my dear, step 4. In the step 4, what you are going to do? You are going to do the process of hydrolysis of diazonium chloride. This is the last step. Okay, so hydrolysis of diazonium chloride. So this is the diazonium chloride. I'm going to make it a small N2Cl minus. Sorry, N2Cl minus. If you react this one with water, HOH, and you provide some of the heat energy, so what would happen, guys? This H and this Cl, that is going to form HCl. That nitrogen would come out in the form of N2 gas, and then you got benzene. And what is left up here? The only thing left, that is OH. So OH would be attached up here. So this is the phenol which is being formed. Okay, so benzene could not be directly changed into the phenol. Keep remember that. Okay, benzene could change into nitrobenzene. Nitrobenzene could change into phenylamine. Phenylamine could change into diazonium chloride. And diazonium chloride, when it is reacted with the water, it is hydrolyzed with the water and heated, it will change into phenol. Did you get it? Muskan, you are late. Did you get it, beta? I have repeated it.
Yes, sir.
Yes,
Beta,
sir.
please give your time. You don't come late. So this was the preparation of phenol. Now we are going to start with the reactions of phenol. Okay, so phenol got the two types of the reaction. एक तो उसके reaction जो है मैंने कल आपको बताया था कि phenol act as an acid, weak acid. तो एक इसके reaction जो है वो acid वाले होंगे. तो any one of you could tell me कि phenol किन किन चीजों के साथ react कर सकता है as an acid? Come on. I told you yesterday. I just want to check. The first thing is metal. Second one, metal oxide.
Metal oxide.
Metal hydroxide. So phenol is unable to react with the metal carbonate क्योंकि एसिड जो है वो चार चीजों के साथ रिएक्ट करते हैं, metal, metal oxide, metal hydroxide and metal carbonate. But phenol is a weak acid. It could react only with the metal, metal oxide and metal hydroxide. Keep remember that. Okay. Whereas the carboxylic acid, it can react with the four substances: metal, metal oxide, hydroxide and metal carbonate. ठीक है? तो फिनोल में और कार्बोक्सिलिक एसिड में डिफरेंस यही होता है कि दोनों में कार्बोनेट डालो तो अगर आपका फिनोल होगा तो इट वुड नॉट फॉर्म एनी एफर्विसेंस, whereas if it is the कार्बोक्सिलिक एसिड तो वो रिएक्ट करेगा, उसमें एफर्विसेंस होगी. एनीवेज ये मैंने वैसे ही आपको बता दिया. तो लेट्स स्टार्ट the reactions of phenol as an acid. As an acid. Okay. This is phenol, my dear. So the first reaction I am going to do. इसका जो first reaction है, if you put it into the water, so that is a weak acid. So reversible reaction that would take place. This H will be given to the water to form H3O positive, and you got this ion which is called as the pheno-oxide ion. So this is called as the pheno-oxide ion. Okay. Okay, my dear, this is the phenol. So phenol would react with the metal. So I'm going to take sodium metal. So what would happen, beta? This H would come out to form the hydrogen, and sodium would be attached up here. So this one O minus Na positive, and hydrogen that would be produced. So 2, 2 and 2. So you know that this is called as the sodium pheno-oxide. This is the salt. Sodium pheno-oxide. That is the salt which is being formed. Okay. So whenever any acid react with the metal, it is going to form salt and hydrogen. So see, this is the salt and this is hydrogen being produced. The third reaction, my dear, this is the phenol. If you react it with a metal oxide like potassium oxide K2O, so it is going to form O minus K positive. So this is potassium pheno-oxide. Plus water that is being produced. And the fourth reaction, my dear, this is the phenol. So react this phenol with the sodium hydroxide. So it is going to form again the sodium phenoxide plus water. Okay. So see, phenol is a weak acid. It could react only with metal, metal oxide, and metal hydroxide, not with metal carbon. The next reactions of it. These reactions are as an acid. The reactions of phenol as an acid. Now we are going to start its normal reactions. Reactions with respect to benzene group. So reactions with respect to benzene group. So these are the second reactions with respect to benzene group. Now everybody just look up here. Last time I told you, my dear, if with the benzene any element is attached having the lone pair of electron, it will delocalize its lone pair to the benzene ring. And what would happen? Due to that, the first thing would happen, the reactivity of benzene would increase. Okay. So without catalyst, it can react with the reagent. So पहला reaction जो हम लोग करने जा रहे हैं, that is with bromine. Okay. So everybody just look up here. If this is the phenol, I'm going to react it with the bromine, and this bromine that is non-aqueous. Non-aqueous means it's not dissolved in the water. Okay. So this bromine. So here you don't need a catalyst AlCl3. Why? Because the reactivity of benzene, it has been increased. If you got the non-aqueous bromine, so what would happen? The bromine would be attached either with the position 2 or position 4. Why? Because this OH is having the single bond and it is 2,4,6 connecting group, and HBr that is being formed. Okay, but if you react this phenol with the bromine and the bromine that is aqueous, We got the aqueous bromine. So again, we don't need AlCl3 as a catalyst. Why? Because I told you in phenol, the reactivity of benzene has been increased as it has delocalized its lone pair up here. Okay, delocalized its lone pair to the benzene ring. Okay. So now, my dear students, if you got the aqueous bromine, so with aqueous bromine, what would happen? Uh, this is benzene, okay, having the phenol group. Now, if it is the aqueous bromine, the bromine would be attached on to three positions or 2, 4, and 6. And we got 3 HBr, and the three molecules of these are used. And this whole thing, my dear, that is called as the 2,4,6 tribromo phenol. Okay, and this one is going to form the white precipitate. Always keep remember, if you got the bromine and the bromine is attached either with the two position of the benzene or the three positions of the benzene, so that whole product would form the white precipitate. Always keep remember. So this is also this could also be used to distinguish between the benzene and phenol. You should add the aqueous bromine in both. Benzene, you know that it is unable to react with the bromine until you are going to add AlCl3 in it. But if it is the phenol, if you add the aqueous bromine, it would form the white precipitate because bromine is attached on position 246, forming the white precipitate. So this one could be used as a test. Did you get it?
सर सर
You
आपने जो वाइट प्रेसिपिटेट का एक सर बताया था कि हमें वो याद रखना है सर, वो दोबारा रिपीट कर देंगे?
याद रखना है, बता तो रहा हूँ कि पोजीशन बेंजीन की दो पोजीशन पे या तीन पोजीशन पे ब्रोमीन लग जाए तो ऐसी चीज वाइट प्रेसिपिटेट बनाती है, बता तो रहा हूँ बेटा।
दो से ज्यादा, दो या उससे ज्यादा लगे तो
जी
ठीक है
जी,
सर।
कोर्स माय डियर। ओके गाइस, now we are going to start with the second reaction of the phenol, that is with nitric acid. So nitric acid, my dear, it would react with the phenol by two ways. If you got the nitric acid HNO3 and the nitric acid, that is dilute. If you got the dilute nitric acid, so what would happen, beta? First of all, you don't need concentrated sulfuric acid as a catalyst. I told you that for phenol, no catalyst they are required. Okay. So what would happen if it is the dilute nitric acid on any one position, the NO2 that would be attached on position 2 or position 4, and H2O that is being formed. Okay. Whereas if you got the concentrated nitric acid like HNO3, this is concentrated. If it is the concentrated nitric acid, so again you don't need the concentrated sulfuric acid as a catalyst. Okay, so in that case, the NO2 group would be attached on all of these three carbons. Okay, and three water molecules they are produced, and three of these molecules they are produced. So this thing formed, my dear, this is called as the 2,4,6 tri nitrophenol, and this is in short form called as the TNP. So this is TNP. अब जरा ध्यान से सुनिएगा सारे बच्चे। You people have listened the name of TNT. TNT का नाम सुना होगा अक्सर कार्टून्स में, वो जनाब वो क्या करता है, इस तरह दबाता है पहाड़ों में और वो इस तरह वो बस यानी जो है ना धमाका सा हो जाता है, you know that of course. तो बेसिकली दिस इज TNP. TNP क्या होता है ये देखें, ये बेंजीन है, दिस इज मिथाइल बेंजीन। मिथाइल बेंजीन को हम लोग टोलीन भी कहते हैं। तो इसकी अगर तीनों पोजीशंस के ऊपर NO2 लग जाए, सो दिस इज कॉल्ड एज द 2,4,6 ट्राइनाइट्रोटोलीन, क्योंकि मिथाइल बेंजीन के लिए एक वर्ड टोलीन भी होता है। ओके, सो दिस इज कॉल्ड एज द TNT। but this TNP that is more explosive as compared to TNT. This is the TNP, but TNP that is more explosive. So if you take the dilute nitric acid, on one position the NO2 is attached on the phenol, but if you got the concentrated nitric acid, it would attach on the three positions of this phenol, forming trinitrophenol. So TNT. TNP. Sorry. TNT. TNP. ट्राई नाइट्रोटोलीन बता रहा हूं, मिथाइल बेंजीन को टोलीन कहते हैं बेटा. ओके, डिड यू गेट इट गाइस? सो ऑलमोस्ट योर चैप्टर इज बीइंग कंप्लीटेड. कल इसका थोड़ा सा है और इसके पास पेपर जो है तो हम लोग सॉल्व करेंगे. सो दैट्स इट फॉर टुडे फ्रॉम माय साइड गाइस. You want to ask me any question, you could.
Allah Hafiz sir.
Allah Hafiz.
अल्लाह हाफिज सर.
ओके, बहुत ज्यादा बहुत मुश्किल है.